lengths of the sides of the triangle. Looking at these two angles, we actually know that these two angles are exactly the same. So that means that the sides are if these angles are the same, then those sides are the same. So let's start by just using those two pieces and say that the x plus 20 equals 8x over 3. To get rid of that 3 on the denominator, we're going to multiply both sides times 3. And make sure you're careful when you do this, that you're using the distributive property and multiplying the whole side by 3. So that becomes 3x plus 60 equals 8x. And we can subtract 3x. I don't know why I wrote it right there. Subtract 3x from both sides of the equation. That leaves me with 60 equals 5x. Divide both sides by 5. And you get the x equals 12. So now that we know what x is, we actually want to find the lengths of the sides of the triangle. So to find PQ, we can just plug in 6 times x minus 12. And on PR, we're going to plug into the x plus 20, and QR, we will plug in 8 times x over 3. And so we are plugging in 12 for x. And when we evaluate that, we get 60, and PR is 32, and QR is also 32. And we came out with 2 equal sides, so perfect. Go ahead and pause your video, do the try it, and come back and check your work when you're done. Part A wants you to find the value of x. So 8x minus 1 should equal 4x plus 5, because those two pieces are congruent. Subtracting 4x and adding 1 gives us 4, and then dividing by 4 gives us 6/4, which is the same thing as 3/2. And to find the lengths of the triangles, to find AB, you're plugging in 8 times 3/2 minus 1, and that's 12 minus 1 equals 11. And let's call this A, B, and C. Then we can talk about it easier. So then we'll say BC can be 4 times 3/2 plus 5. And that should come out to be 11 also. And then AC is 2 times the 3/2 plus 11. So that becomes 3 plus 11, which equals 14. 11, 11, and 14.